This lesson is all about statistics and probability using center and spread. It says, how can you describe and compare data sets? So Caleb and Kim have bowled 3 games, and their scores are shown in the chart below. We are going to complete the chart by finding Caleb and Kim's average score over the 3 games and place that answer in the table. Remember, to find an average, you add up the data values and divide by how many data values there are. So for Caleb, we are adding his 3 values, and then we will divide by 3. For Caleb, we have 151 plus 153 plus 146 is 450. And when you divide by 3, his average is 150. Then we need to do the same for Kim. We have 122 plus 139 plus 189, which is also 450. So they have the same average. It says Caleb and Kim's scores, whose scores are the most consistent? So if we look at Kim, she has a score of 122 and a score of 189, which are pretty far apart. But the farthest scores for Caleb was only from 146 to 153. So Caleb's scores are more consistent. Then it says Caleb's scores are either farther from or closer to the average than Kim. Well, we see that 153 is only 3 away from the mean. 146 is only 4 away from the mean. But for Kim, 189 is 39 away from the mean. So Caleb's scores are closer to the average. It says they bowl a 4th game where Caleb scores 150 and Kim scores 175. How will that impact their averages? So if we add another 150 to 450, that would give us 600. And 600 divided by 4 data values is still 150. But if we add 175 to 450, that gives us 625, and we have to divide by 4. So she now has an average of 156.25. Does the game 4 score affect the consistency of their scores? Explain. Well, Caleb's scores are still pretty consistent. As he's around 150. And Kim remains inconsistent. So no, it does not impact it. Then in question 1, it says, is the average an accurate representation of Caleb's bowling? Yes, because he is around 150 for each of them. Is an average an accurate representation for Kim's bowling? And the answer to this one is no. Because she is inconsistent, the mean is not the best measure. Measures of center, mean and median. So there are multiple measures of center. Mean is just the one that we see most often as an average. It says 2 commonly used measures of center for a set of numerical data are the mean and median. Measures of center represent a center or a typical value of a data set. The mean is the sum of the values in the data set divided by the values in the data set, the number of values. The median is the middle value in a set when they are arranged in numerical order, so from least to greatest. In A, it says, find the mean and median of each data set. The number of text messages that Isaac received each day for a week is shown. Finding the mean. He adds them all up and he divides by 7 because it's for a week. 1, 2, 3, 4, 5, 6, 7 data values, which gave him a mean of 50. Then to find the median, they had to put them in order. So the 47s went first, then the 48, 49, 50, and so on in numerical order. I like to cross off like this, 1, 1, 2, 2, 3, 3, so I make sure I have the same amount on each side. And the number in the middle is 49, which represents the median. Now we're going to try. The amount of money Elise earned in tips per day for 6 days is listed below. Find the mean to the nearest penny. So we first have to add all those numbers up. Take a second and do that right now. You should get 835. And when you divide that by 6, 139.17. Remember, rounded to the nearest penny. So the mean is $139.17. Then find the median. We have to list them in order. I see 75. The next smallest looks like 84. Then we have a 97, 100, 119, and then the largest is 360. So when we have a middle number that is only 1, we just use that as the median. But since on this one, there are 2 numbers left in the middle, we have to find the average of those 2. The thing in between 97 and 100 will be the median. So we add those up, and that gives us 197 divided by 2 is 98 and a half. Question 3 says, for the data on tips, which measure of center is more accurate in describing the typical value? And explain. If we look at the mean, 139.17, that's larger than all except one data value. So the median gives us a better prediction or a better estimate of the center. Let's go ahead and write that in number 3. Now we're going to find the mean and median of each of these. So you're going to start by writing them in order. For the median, cross off 1, 1, 2, 2, and we're looking in between 72 and 73. Now for the mean, add up all 6 values and divide by 6. Remember in your calculator to hit equals or include parentheses around your sum before dividing by 6. Otherwise, it will just divide the last number in the row by 6, and you don't want that. And you should get 76. Raul recorded the following golf scores for his last 7 games. Again, place them in order from lowest to highest. And we are going to cross off 1, 1, 2, 2, 3, 3, and there's 1 value in the middle this time, so the median is a number in the list, and it is 90. And go ahead and add these all up and divide by 7. You should get that the mean is about 89.3. So then we have other measures that we use besides just the center. We also talk about the spread of a data set, or the spread of, sometimes they call it a distribution. It says, measures of spread are used to describe the consistency of data values. They show the distance between data values and their distance from the center of the data. 2 commonly used measures of spread for a set of numerical data are the range, which goes from the smallest to the biggest, and the inner quartile range. So the definition of range is the difference between the greatest and least values. Quartiles are when we split up our data into 4 equal parts. The first quartile is the lower quarter. Then we have the median, which represents the lower half, or the second quartile. Then we have quartile 3, which represents the first 75%, and then we have the final value, the maximum, which would be the final highest number in our data set. The inner quartile range is the distance between Q1, first quartile, and Q3, the third quartile. We learned this stuff back in 6th grade, so I know it's been a while because we have not seen it since then. So it says, the median, if we put them in order, we would cross off 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, and our median would be 5. And then we're going to use the data that's left to figure out the quartile. So we'd go 1, 1, 2, 2, 3, 3, and our quartile 3, the upper quartile is 7. And then over here, 1, 1, 2, 2, 3, 3. Q1, that lower quartile is at 3. So for the range, we look at the smallest and biggest number and we subtract. For the inner quartile range, we look at our quartile values for quartile 3 and 1, and we would do 7 minus 3 is 4. Find the median, range, and inner quartile range for the given data set. The April high temperatures for 5 years in Boston are 77, 86, 84, 93, and 90. First, we have to order the data values, so they've put them in order. They're going to cross off one from each side until they get to the middle, and they found that the median is 86. The quartiles, we have to figure out, okay, this is the median, so then what's in between these data values here? And you can see they took 77 and 84 and figured out what was in the middle. So Q1 is 80.5. And over here we have to figure out, well, what's between 90 and 93? And that was 91.5. The range goes from the highest to the lowest. And the inner quartile range goes from the high quartile to the low quartile. That math is not correct there. 91.5 minus 80.5 is not 1. It should say 11. Somehow I'm missing a number. Anyways, moving on. The numbers of runs scored by a softball team in 20 games are given, and they are not given in order. Great. Okay. Here we go. We have 2, 3, 3, 3, 4, 4, 4. There is a 5. I don't see any 6s. There's 2 7s. An 8. Another 8. A 9. A 9. They got their 10s taken care of. The 11, the 12s, and the 14. All right, now we have them in order. So it tells you the median is between 7 and 8. So to figure out what's between them, 7 plus 8 is 15. 15 divided by 2 is 7.5. The range from the high number to the low number, 14 minus 2 is 12. Now we have to find the quartiles. So we know that the median was between these two numbers, so the 8 and the 7 get to be part of the quartile pieces. So here we go. 1, 1, 2, 2, 3, 3, 4, 4. Well, what's in between 4 and 4? 4. Okay, then Q3. 1, 1, 2, 2, 3, 3, 4, 4. We have to add 10 plus 10 is 20. 20 divided by 2 is 10. So there are our quartiles and our median. The inner quartile range goes from Q3 to Q1. 10 minus 4 is 6. The median we said was 7.5. The range was 12, and the inner quartile range was 6. Why is the inner quartile range less than the range? The range is from they call them the extremes, the upper extreme and lower extreme, but that's just a fancy way of saying from the minimum to the maximum. But the IQR isn't from the lowest piece to the highest piece. It's from the lower 25% to the upper 25%. Another way of saying that is that it's inside the data set a little way, so it's not going to be as spread out. They said here the IQR is the difference between the numbers within the set. So it should be less. It could be equal, but it will never be more. All right, find the median, range, and interquartile range for these values. Again, we have to put them in order. Okay, so to find the median, we find the thing in the middle, and it's between 26 and 26. So the median has to be 26. The range, we would subtract 31 and 21, which gives us a range of 10. For the interquartile range, we're going to cross off, and we've got, that would be Q1, and this would be Q3. So for our interquartile range, we're going to take 28 and subtract 24, which gives us an IQR of 4. All right, the high temperatures in degrees Fahrenheit for 11 days. Again, we need to put them in order. AC is 68. There are 3 71s. Two. All right, let's start with the range this time. We went from 79 to 68. That is a difference of 11. For the median, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. The median is 73. Now, because that's one single value, that 73 does not get included in the lower or in the upper half when we are trying to find our quartiles. So we're excluding that number. 1, 1, 2, 2. Q1 is 71. 1, 1, 2, 2. Q3 is 75. So our IQR is 75 minus 71. Alrighty. Sorry guys, this is a long one. Now we're looking at what's called standard deviation. This is something that you have not heard of unless you've taken a statistics class or your parents talk about it. It says, another measure of spread is the standard deviation, which represents the average of the distance between individual data values and the mean. It's a measure of how spread out the values are from the mean typically. And it uses this formula, which is a very fancy way to write down you're subtracting things, adding them together, and dividing by how many. It's pretty much like finding the mean, but there's an extra step in there, an extra 2 steps really. So to find the standard deviation of these values, we first have to find the mean. That's what that little X with the line over it's talking about. This represents the mean. Whoops. That's what they're talking about there. Some people call it, I think X hat is the correct term for that. No, X bar. This one is X hat, this one is X bar, but that's terms that you'll need later on in math. Okay, so find the standard deviation of those numbers. We're going to find the mean. They've added up all the data values in the set and divided by 5 because there were 5 data values. And they got a mean of 86. Now, the piece where it says x1 minus x bar, we are going to subtract each of these numbers, so 77, from 86. We're figuring out how far the data values are from the mean. So you can see in this table, they took 77 and subtracted 86, 86 and subtracted 86, 84, 93, and 90, all taking away the mean. And they got these values here. Then in the formula, it says we have to square that. So instead of just adding them up and dividing by how many, we want them to be positive numbers. So one way that we can do that is we square each of them, because a negative squared comes out to a positive. A negative squared comes out to a positive. So there's all of those pieces that we have for the numerator. And it says, then divide by how many? So you can see here, they took all of these, added them up, and divided by 5. And they got 30. But that's not the final step. In a standard deviation, you also have to square root it. So find the square root of the mean of the squared deviations rounding to the nearest tenth. So square root of 30 comes out to around 5.5. Now it's our turn. And it's a lot of numbers here. So we have like a whole page of space to write down our work. It's okay. They are adding all of the pieces on the top, and they're going to divide by 20 because that is how many is in the list. Go ahead and find the sum of all of those numbers. You should get 145. And then we would divide 145 by 20 because there are 20 numbers in the list. And that gives us 7.25. Then we're going to take that number and we are going to figure out how far apart every single one of those numbers in the list is from 7.5. Here we go. That is negative, oh, it's not 7.5, 7.25. Yeah. Negative 5.25. 3 minus 7.25 is negative 4.25. 3 minus 7.25. These are all the same, so we're going to write that down again. Okay, 4 minus 7.25. That gives us negative 3.25. And these are all the same. Okay. 5 minus 7.25 is negative 2.25. 7 minus 7.25 is negative 0.25. 8 minus 7.25 is 0.75. 9 minus 7.25 is 1.75. And the next one is the same. That would be 2.75. 3.75. All right, then we have to square each of these things. So back to the top of the list. Negative 5.25 squared. Negative 4.25 squared is 18.25. 0.0625. This one we need to square negative 3.25, and that gives us 10.5625. Okay, I'm going to continue working on these, but I'm going to have you pause the video and finish them up, and then you can come back and just really quickly check and see if you've got them all filled in correctly. So you're taking the values here and squaring them. Okay, there's the list of all of the deviations squared. And then we have to add them all up. Yeah, I feel the same. So, add them all up. I'm just going to write some in here because I'm not going to rewrite all of those. But we are adding all of those squared values together, and then we are dividing by 20. When you add all those things together, you get 245.75. And dividing that by 20, you end up with 12.2875. And we have to square root it. I need to write smaller, apparently. 12.2875. And the square root of that comes out to 3.5. So a standard deviation is approximately 3.5. And there are plenty of people who do not do this by hand. We use spreadsheets for things like this, and you can put all of that information into like a Google Sheet or an Excel, or if you're using a Mac, you can use numbers, and the spreadsheet can do all these calculations very quickly for you, but it's important to know the process. So when you're finding a standard deviation, the process I have to teach you, but in reality, I don't think you're going to do this by hand in real life ever, unless for whatever reason the world comes to an end and you don't have a computer. 9. In terms of data values used, what makes calculating the standard deviation different from calculating the range? Well, the range is just a spread from the smallest to the biggest. But the standard deviation measures the average distance from points to the mean. In 6th and 7th grade, we learned this in terms of what's called MAD, mean absolute deviation. Instead of using standard deviations with all the squares and square roots, because as a 6th and 7th grader, we don't use those, we used MAD. But this is a more common measure of distance between the mean and the points. So we're going to do this one more time. but with a much smaller list of values. So hopefully it doesn't take us as long and it makes a little bit more sense. First and foremost, we need to find the mean. Add up all of these values and divide by 1, 2, 3, 4, 5, 6. So the mean is 26. In the first row, we are going to find the deviation. So we're doing 21 minus 26. 24 minus 26. 26 minus 26. 26 minus 26. 28 minus 26. 31 minus 26. And then in the next row, we are going to square those values. 5 squared is 25. 2 squared is 4. 0 squared is 0. 2 squared is 4. And 5 squared is 25. Now to find the mean absolute deviation, the standard deviation, we are adding up those values. 25 plus 4 plus 0 plus 0 plus 4 plus 25. And we are dividing by 1, 2, 3, 4, 5, 6. And then we have to square root that value. Now, it doesn't come out to exactly 9.67, so you're going to want to use the full number in your calculator and then approximate at the end. So this comes out to about 3.1. I lied. We have to do it once more without the table. Okay. Add them all up. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values. All right, we're not going to do it in table form. We're just going to figure out how far apart they are from that mean. So how far apart is 68 and 73? 69, 70, 71, 72, 73. They are 5 away. And then we'll square that. How far away is 71 from 73? 2. How far away is 75 from 73? Also 2. 74 is 1 away. 75 is 2 away. 71 to 73 is 2 away. 73 to 73 is 0. 71 to 73 is 2. 72 to 73 is 1. 74 to 73 is 1. And 79 to 73 is 6. You do not have to square them and then add. On your calculator, you can do that all in one step. And you should get all of that divided by 11 gives you about 7.64-ish. But to find the standard deviation, we still have to take the square root. We're undoing that square step. And we get about 2.8. is a long process. Okay. In 11, what is the mean of the deviations before squaring? We did not do that because we did it all in one step. The reason that they're asking that question is because they don't want you to add the positives and the negatives together because it could give you 0. That's why you're squaring things. So that way you get rid of that and you don't add things up to 0. You want all of those distances still accounted for. 13. How can you determine the first and third quartiles of a data set? You start in step 1 by finding the median. For quartile 1, you find the median of the lower half and then you find the median of the upper half for quartile 3. 14. How can you determine the standard deviation of the data set? You use the formula. You start by finding the mean. Then you find out the deviation from the mean. Then you square those. Then you find the mean of those. And then you square root it. What does the measure of center of a data set indicate? It indicates a typical value. It tells us what's typical. For the bowling, what was our typical score? Okay. Sorry it was such a long one. Fortunately, this isn't something you do all the time unless you are taking statistics, which some of you may do, some of you may not. And you have some practice. Again, you kind of decide how much you need, how much time you take to figure out if you know it or not, and you can also do some stuff online if there are any Delta Maths or those sorts of resources on finding center and deviations.